So welcome everybody to another video on scatter diagrams, and in this video we'll be looking at drawing and using a line of best fit on your scatter diagram. So if a scatter diagram shows correlation, whether it be positive or negative, we can draw a line of best fit to represent the expected value. So for example, you can see here that we've got a negative correlation because our points are going downwards. So as age increases, the value will decrease, and it's talking about the value of a car. Now, as you can see, in terms of the values that we're looking at, that we tend to have the values that are following this kind of nature. So there's at the smallest, all our points are within those two dashed lines. So what you want to do is draw a line of best fit is there to represent where those points should really be. So if there is an actual relationship between the two, which there looks like to be, then what you want to do is draw a line that represents all of those points. And this would be what we call the expected line, or the line of best fit. And there would be values, and what this line represents is the expected value. So for example, if you've got a car that's worth 7 years old, then we can use this line rather than the two values that I've got, because one 7-year-old car was worth £2,000, another was worth £4,000. So the line would represent the value that's what it should have been for this particular make of car. And obviously we can tweak that in terms of making the line as close as possible to all the points, which is never going to be as accurate, but you try and want to have some boundaries in terms of what it would be expected to be. So let's have a look at drawing a line of best fit. Now, when drawing a line of best fit, there's a couple of things that you need to bear in mind. So that first one is that it should be a straight diagonal line drawn with a ruler, and preferably a transparent ruler. A transparent ruler will just enable you to look at the points rather than just simply looking at maybe the top half or the bottom half, depending on where you're about to draw your straight line. Now, the second one is that your line of best fit doesn't have to start at the origin. Now, again, this is a big misconception, the biggest error that a lot of students make, particularly especially when you've got positive correlation, that they automatically think that the line of best fit has to start at 0, 0, or the origin, which is not true. Now, it can also can and doesn't have to go through any of the marked points, so you don't have to avoid the line. Now, generally speaking, you want to try and make the line as close as possible to all the points, which is basically going on to point 5. So before we do that, let's have a look at point 4, which is to try and have the same number of points above the line as we do below. Now that there, now just highlighting some of the key points, is that it needs to be a straight diagonal line, unlike my highlighting. It can and doesn't have to go through any of the marked points, and again, you also want to try and have the same number of points above the line as you do below. Now again, that might not be as possible, so for example, you might have 4 points out below and 3 below, which is absolutely fine. As long as the numbers are close, then that's going to be fine. As long as you haven't got like 7 above and 2 below, then that's going to be a little bit sketchy. Now the fifth point, again as mentioned, is that you want to try and be as close to the points as possible. Now again, it is going to be difficult, so you kind of have to use your common sense about where you're going to position your line. Now, point 6 is that you should always extend the line of best fit so that it crosses the axis or goes beyond the points plotted. And again, this kind of comes from by when you asked later on in questions where you're asked to use your line of best fit just to extend it that little bit further. Now, if you are studying higher GCSE or GCSE statistics, then one extra thing that you might have to do is that your line of best fit should go through the mean of x and the mean of y as a coordinate. Now, again, I will mention this briefly when I show you the data, when we go through some examples, but I would say step 7 is not going to be essential if you're not doing GCSE statistics or a higher level of maths. So let's have a look at some examples. So let's take the original example that we did at the start of the video. So here we've got a scatter diagram that shows the value of cars in a used car garage are recorded below. The scatter graph that shows the information. What we're going to do is we're going to draw a line of best fit to represent this data. Now you can see here that before I get started, let's just count how many points we've got. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I'm drawing my line of best fit, and again, it's going to be kind of just guessing, so I'm just get rid of the highlighter and get an actual colour pen. So when I'm drawing my line, I want to try and be as close as possible to the points. Now, obviously, if you're using a ruler and definitely a pencil, you kind of might want to tweak where you put your lines. Now, again, your line of best fit might be different to what I'm doing on screen, or it might even be different if you're doing in class to the person next to you. But generally speaking, I'm going to go from a line of best fit being there. So you can see it's a straight line, doesn't have to go through the origin, which is going to be near impossible for this because it's got negative correlation. And you can see if I count the number of points, I've got 1, 2, 3, 4 points above the line and 1, 2, 3, 4 below the line. And also my line of best fit kind of just almost goes through 2 points that are on there. So that would be absolutely fine as my line of best fit. Now notice how I've also extended the line so it crosses both axes. Now again, that's not essential, it doesn't have to cross both axes, but I certainly would extend the line beyond the point. So what I'm saying is, don't do a line of best fit that just looks like this. You want to make sure that it does go through and extend that line so it kind of just is almost the same size as your graph, and we keep it as there, and that will be my line of best fit. So let's do it for another graph. So here we've got positive correlation, and this is looking at the height and arm span, I'm guessing, of some human beings. So let's draw our line of best fit, and again it just might take a little bit of tweaking. You might want to have a look, and I want to say roughly going to be around about there. Let's just move this one just to make sure. So go for there. So again, it's going to be slightly different. Now what you'll find is that when marking in GCSE papers or classwork, that the examiners will have like a boundary where you expected your line to be. So as long as your line is within a given range, so for example those blue lines there, then you're going to get full marks for it. And any answers that you'll use your line of best fit will be based on the line that you've drawn, rather than, let's say, questions on a mark scheme, but you'll always get ranges of what values that should be. So yeah, so now the one thing that to bear in mind is that if you have got a scale break, which is what we've got here, if I just highlight a different color, so let's just put that in yellow here, then what you might find is that it may be difficult for you to cross the axes. Now if your line of best fit is above the scale break, then that's going to be absolutely fine. So for example here, if I extend my line of best fit, I can make it cross that axis. However, if my line of fit was going to go like this, then it wouldn't be necessary for me to cross the line, because I don't know where that line of best fit crosses the x-axis. So just be mindful that when you have got a scale break, that your line of best fit doesn't necessarily cross that axis unless it's above the scale break. So let's have a look at another example. So here, now if you're doing high level maths or high level statistics, then when we talked about the mean of x, so if I imagine that this is the horizontal axis and this is the vertical axis, now what I'll need to do is I need to find the average or the mean of these values. Now again, if I quickly just work that out, so I've got plus 1 plus 6 plus 3 plus, let's try this again. So all in all, I get that as being 45.5 divided by, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divided by 10, so that is going to give me 4.55. And if I work out the mean of y, so here I've got 90 plus 20 plus 38. And that gives me an answer of 572 divided by 10, so that's going to give me 57.2. So my coordinate is 4.55 to 57.2. So if I mark that on my scatter diagram, so 4.55 is there and 57 roughly about there. So this is basically my mean of x and my mean of y. Now when I draw my line of best fit, it should go through that value. Now again, if you're just doing normal GCSE maths, then this is not going to be essential. You don't need to work that out. It's only if you are doing high level statistics or GCSE statistics that it might come into question. So for example, looking at that, yeah, I would say that's pretty much okay. I'm happy with that, because you can see there, I'll just move this slightly up a bit. You can see that I've got 4 points above the line and 3 points just below the line. If anything, I might just have to tweak it like so, and that'll be fine as such. But like I said, your line of best fit might be different to someone else's, so I'll leave it as that. So again, let's just move that. Okay. So from that, and again, obviously that green line should touch that dot, which it doesn't. Now it does. So there we go. So let's have a look at using line of best fit. Now, as he's talked about, is that you can use your line of best fit to find out what expected values are. So for example, we take this example here. So here it says, again, is we've got test scores against the hours spent revising. Now, so the question is asking us, using our line of best fit, what score would you expect after 6 hours of revising? So for this, what we need to do is we need to find 6 on our axes, which is going to be this block here. And I think the scale is slightly off. It should be where the actual boxes are marked. So I'm going to go up to 6, going upwards. And as soon as it hits the line, I'm then going to project across to where it hits. And this value here will be my answer. So I'm looking at being about 66%. So I would say my answer there would be 66%. Now again, in the mark scheme, they may say any answer between, let's say, 60 and 70, depending on what you've drawn, how you've drawn your line of best fit. So again, your answer might be different to a person one sitting next to you or someone else who's done the question, but as long as it's within the range, then that's going to be absolutely fine. The next question says that Tyrone scores 80%. Estimate how much time he spent revising. So again, this time we need to go in the opposite direction. So here we're looking at 80%, which is here. So I'm going to draw a horizontal line till it hits my line of best fit, and then I'm going to project downwards. Trying to be as accurate as possible. Using a ruler would definitely be essential here. So we work it out as being 7.6 hours. And that would be my final answer. Now, the next question then says, explain using a line of best fit for this data to predict the values may not be appropriate. So here you could say, now this is basically kind of saying why do you not draw a line of best fit, or why is it not appropriate in reality? Well, for reality, it basically kind of says that if you do 0 revision, that you're expected to get around about 20%. Now, depending on if you just walk into an exam, well, that might be different because you might have some prior knowledge that you kind of vaguely remember. But if it's something like, for example, me studying, I don't know, sort of sewing, then I would have absolutely no skill in that. So I couldn't do an exam, so I would pretty much expect to get 0. And also, to get 100% in this test, you're kind of expected to do just about 10 hours of revision. Now, that might not be true because it depends on the quality of revision that you're doing. So it depends on also is implying that what you're revising is definitely going to come up in the test. So anything along those statements would be absolutely fine to kind of criticize that line of best fit. Let's move on to our last example here. So again, it says that Jessica was absent for the so here we've got a scatter diagram first. It's got non-calculator against calculator scores. So it says Jessica was absent for the calculator paper but scored 80 marks on the non-calculator paper. Use the line of best fit to predict her paper 2 score. So again, here what we're going to do is we're going to draw a non-calculator, which is 80. I'm going to draw a vertical line until it hits my line of best fit, which is here. And if I just emphasize the line of best fit in case it's difficult for you to see on the screen. There. And as soon as it hits that line, I'm then going to project across like so, trying to be as straight as possible. And I work that out to be around about, so each block is going to be, so it's going to be 4, so it's going to be 156 to be her estimated score. Then says Jorge was absent for the non-calculator paper but scored 60 marks on the calculator paper. Use line of best fit to predict the non-calculator score. So this time I'm going to go for the calculator paper, which is 60. I'm going to scroll across, and let's try and use a different colour. Let's go for green. So I'm going to scroll across till it hits the line of best fit, and then I'm going to project downwards, and I get a score of round about 34 marks. So again, 34. Again, your answer might be slightly different based on the line of best fit that you've drawn, but as long as you've predicted from your line of best fit, then that's going to be absolutely fine. Now, we'll put some practice questions in the description below along with the answers for you to check your understanding of everything that's covered in this video.